Hi guys, N0ECK here again, and today we're going to build an HF beam for less than $50. So I was at the farm store looking for parts for antennas. You know, the end insulators from electric fence work pretty well. Either way, I found 9-foot fiberglass rods they use for tile markers. Added an SO239, a piece of wire, and some radials, and you've got yourself a vertical that can be up to 9 feet long. Works pretty good for 10 meters. So I've got a 10-meter vertical. I've used it. It works pretty well. But today, we're going to take that concept and turn it into a 10-meter beam. So what you're going to need for the project are 4 of those 9-foot tile markers, one 10-foot stick of 1-inch PVC tube. I prefer the white PVC tube because it is RF transparent. Some method of connecting that to your mast. Also, I'm going to use a rope as a rotor, so I'm going to use this to produce myself a little rotor thrust-bearing type assembly for my portable antenna, some ring terminals, and then some tape and miscellaneous. I'm going to use some 14-gauge wire that I bought a long time ago for antenna projects. It has lasted forever.
I looked online and found many plans for 2-element beams on 10 meters. I found several calculators for direct feed Yagi dimensions, and they all agreed on what's listed here. There were other plans with different spacing, but they all use solid elements and some kind of gamma match at the feed point to make 50 ohms. I started by using my trusty tape measure and cutting the elements to length.
Alright, so I soldered the driven element to a piece of scrap coax that I'm going to use as a balun. Most of the time I don't bother with baluns because, well, omnidirectional antennas usually don't need them unless there's, RF interference in the shack. But this time it's probably a good idea. I'm going to tape these up and make sure they're, not shorted.
I wound 10 turns of the coax around the boom to form an ugly balun. This should keep the beam's pattern a little closer to the models. The predicted gain for this beam is somewhere between 3 and 6 dB over a dipole, depending on who you believe. My makeshift thrust bearing slides right into the bell end of a 10-foot stick of Schedule 40 electrical conduit I had left over from trenching in some coax. I tested the antenna at 10 feet this time, but the normal mast I will use is 23 feet of PVC stiffened with 2x2 lumber.
Well, it's a little droopy, but it seems to do the job. The 50 ohm dip is right at 28.000. I did have to cut a couple inches off the driven element. Of course, I left the reflector as it is because a little long isn't going to hurt it. I still have to drill the holes for the reflector, and drill out the center there so that I can have something other than a zip tie holding that. But as far as temporary setup, it seems to work pretty well. Should collapse down to 9 feet to fit in the back of pretty much any pickup and most cars if you flip the back seat down. 7-3, join the resistance.